Okay, I want to talk about how to use reduce to solve a technical interview question. Over on Free Code Camp, they're asking you to find the symmetric difference. What is symmetric difference? Basically, it is the opposite of what do these two items have in common. So if I have two arrays and they both have the number 3 in them, we would say they have the number 3 in common. Well, symmetric difference is the opposite of that. What items do these arrays not have in common? You can see here that 1, 2, and 3 compared with 2, 3, and 4. The items that these two lists do not have in common are 1 and 4. Now this sounds complicated, and it kind of is, especially when you're being asked to evaluate more than 2 arrays, more than 2 lists. But they're clear here that symmetric difference is a binary operation, and you're not being asked to compare all 3 at one time. You're being asked to compare 2 at a time, get the result of that, compare that result with your third array. Let me show you why that's important. I want to be crystal clear about that. You can see here that the symmetric difference of A and B is 1 and 4. If you compare 1 and 4 with C, well, there's nothing in common, so the final result is 1, 2, 3, and 4. Now, if you were being asked to compare all 3 at one time, C would get totally rejected because C has 2 and 3, and so does A. But that's not how symmetric difference works, so we don't have to worry about that extra complication. Just compare 2 arrays at a time, get the result of that, compare that result with your next array, and so on and so forth. As complicated as that sounds, reduce comes to your rescue by allowing you to focus on this right here. Look at this wording. Create a function that takes 2 or more arrays and returns an array. That's reduce thinking. We're going to reduce these arrays down to one array. So let's go over to VS Code and see if we can't figure this out. I've written the framework of the function, but there are 3 things that I need to give you an overview of so that they don't surprise you as we go through this exercise. We're going to be talking about JavaScript sets, and then we're going to use JavaScript Array.from. The Array.from tool, if you just translated that into English, you're saying JavaScript, give me an array from whatever I pass in here. And JavaScript sets, well, I'll just have to explain that as we go through. But we need sets to keep this function efficient, and we need Array.from to turn what we get from this code block to turn it back into an array. Down here, I'm going to run the function console log its result, and I'm giving it 3 arrays as arguments. All right, let's jump into this. First of all, what the heck am I doing here? Well, the question asks us to evaluate 2 or more arrays. So we need a function that can take a varying number of arguments. That's what this handy little device here does. JavaScript allows you to create functions that create a varying, or that accept a varying number of arguments. You use the 3 dots, and then you give it a name. How then do you use what is passed in here? Well, when you use this tool here, JavaScript, your function sees what's passed in here as an array. It takes it as an array. If it's an array, then I can reduce it. So let's go ahead and set up our reduce function. You know that reduce takes a callback function as its first argument. Notice that in order to use what's passed in here, all I need to do is use the variable I gave it. In other words, I don't have to use this. I don't have to add periods. Now, in order to keep things efficient, we're going to have to tap into the power of a JavaScript set. So let me write the lines of code here. What is a JavaScript set? It's a very powerful, very fast, specialized JavaScript object. And the one thing it does really well is that it allows no duplicate values, and it allows you to find what's inside of it really, really quickly. So if I want to add something to a set, say I wanted to add foo to set 1, I use the special set method called add. Add is a set method. You can't just use this on anything. If I wanted to add foo again on the next line, what would happen on line 8 is simply nothing. Set would just deny it. It wouldn't add foo again because sets allow no duplicate values. It wouldn't throw an error. It wouldn't waste any time with it. It's extremely fast. It just wouldn't add it. There's another handy method that sets have called has. Line 8 would produce a Boolean value, and it would be true because foo is of course in there. Another handy method is delete. If I wanted to delete foo, it's as easy as that. Okay, so at this point in our code, what we're going to do, we've created two sets, and now I want to convert these arrays into sets. And that's as easy as passing arguments into our brand new set instances. Now, here's what my arrays look like to my code. No longer are there all these threes. Set is going to get rid of all that stuff, and what's going to remain is simply 1, 2, 3, 1, 2, 3, and 300. So now let's ask a few questions of our sets. If set 1 has the item, do something with it. Of course, this does not need to be here. It needs to be here. If set 1 does not have the item, then I want you to add it. All right, what is going on in this code block here? Sets are objects. You can loop over objects using the for of loop. If you want to loop over the values of an object, you use for of. If you want to loop over the keys of an object, you use for in. As I loop over set 2, I'm asking a question. Does set 1 have the item we're looking at? If it has it, then delete it from set 1. If it doesn't have it, then add it to set 1. When you're all done, return set 1, and then go to the next iteration. Now, this code block here is not our function. It's inside of our function. So right now, nothing is going to be returned. We need to return a value. So at the end, we want our function itself to return something. We want it to return an array, but how do we get the results of what happened here? Well, just store it in a value. So we'll call it const final. So I'm asking JavaScript to store in the variable final whatever it comes up with here. What it comes up with will be a set, so I need to convert it back into an array. Final. Okay, before I go any farther, let's just run it and see what result we get. As you can see, the function worked. We have reduced these arrays down to a single array consisting of the symmetric difference between all three of them. Now the rest of the video, I'm going to break this down. If this has been helpful, like it, and I'll see you next time. But if you want to hang out, please do that as well. How in the world did this work? The way to find that is maybe to put some console logs in here. The first time through, accumulator was this first array, current value was the second array. We converted those two arrays into sets, and then we console logged those sets. Well, what are those sets? Right here. The first one consists, just like I told you, 1, 2, 3, and 300. See, it got rid of the duplicates. The second one consists of 5, 7, 3, 400, 2, 308. Down here, we're asking those questions. We're looping over set 2, which is this long one here, and we're going item by item asking, is this item in set 1? If it is, then delete it from set 1. Because if both of them have an item, then we know that can't be symmetric difference. So we're going to delete it from set 1. If it doesn't have it, then add it to set 1. Now the question is, why did we loop over set 2 and compare it to set 1? Why does any of that matter? The reason is because of the way reduce works. The accumulator is a critical item in the reduce method. The accumulator is the one that keeps track of everything that's going on, and at the end it's what gets returned, and then when the reduce function goes back through your array, accumulator gets reset to whatever we returned down here. And you should be able to see that in the console log. We've taken these two sets, we've evaluated them, we've added and subtracted from this first set based on what's in here. If they shared items, we subtracted it from set 1. If they did not share the items, we added it to set 1. So on line 15, where we've console logged the result of this code block here, you can see this is the symmetric difference between these first two arrays. So when we go to the next iteration, accumulator gets reset to whatever we returned here. Line 7 equals what we returned on line 15. Accumulator now equals this, and then we're evaluating the last array, which we turned into a set. Because we returned a set on line 15, of our final iteration, we needed to turn it back into an array using the Array.from. If you want to make it even nicer to look at, you can use sort. All right, here's the result. We have a nice array in ascending order consisting of the symmetric difference between all these arrays that we passed in here. If this video was helpful, I hope that you'll like it, and I'll see you next time.